So, welcome back everyone, and this is the last lesson in our digital and analog communication basics. So, here I would like to mention first that what is the parity? Well, this is the first question every engineer should ask, that why I am learning this and what it actually means. So, if that question started bothering you, well, you became an engineer, my dear friend. So, congratulations. Okay, so what is a parity means? Well, this is the extra bit that is added with digital information packet. Like, let's say you are sending some information from at transmission end, and your information is 00111010. So this is the information you are transmitting. So I add 1 here, and this 1 is the parity bit. The 1 in this case, 1 is the parity bit. So you might be pondering that why do we use that? Well, you can use 1 or 0, any of that. That completely depends upon whichever line or way we used to choose. So we can choose 1 or 0. I chose the 1. Okay. So if you count it down, 1, 2, 3, 4, 5, 6, 7. So by adding the last 1, or the parity bit that I have added is making it either odd or even depending upon the message. Like if you have just 001 and I add my parity as 1 with the message, so I made it odd by parity. And if you have 0011, actually I made even, in this case, even parity, even after using the parity. Like this is 1 2 3 4 4 numbers are there. Now if you are having these numbers like 0011, and if I add 1 here, so this is, after parity, this becomes odd. So what actually means with that? Well, just imagine if I tell you that whatever message I am going to send you is always going to have even number of bits, always, including the parity. So it means I am sending actually the odd number of bits. Like let's say the first example, 001, and the second one is 0 um, 1101, and the third one 0101. And let's add the parity bit, 111. Now I told you somehow that I am always going to send you the even number of bits including parity bit. So if you count it down, what is going to come? Well, here it's the 4 terms, so the message is correct. Now in this case we have 1 2 3 4 5 6. So 6, it's even 2, it is correct. 1 2 3 4 5. Now in this we have 5 bit. Well, it's the doubtful case. So what we do with our doubtful case, because I already told you that including parity there is always even numbers. So in this third portion we realize that there is something wrong. So what can be the possibly wrong in this? Well, the possibility of being it wrong is because of the noise added in between added in between the transmission. So when the noise is added between the transmission, this is what is causing 1 extra bit. So I realize that something is wrong here, and we can correct it, or we can actually at least know that it needs to be corrected. So we can have our error correction methods. So here is the solution that we have figured out, error correction. But as an engineer, we always must be questioning. Like, if you are my type, you surely have asked, what if there are two extra bit added in the first one? Like in this one, let me show you. If I add 0, 1, so now the real problem is, one is the parity bit that I sent, so it is correct, but the 0 is the noise, but you are not able to figure out because this 0 and 1 is actually the noise, and the message is, instead of the 4 it gets 6, so it is the even parity, so it's even. So you feel that it's correct, but it's not. And that is one of the biggest problem in the digital message transferring services that we are not able to solve. In the case of the even parity, we need something more. And that's why we follow a particular transmission, that how many bits we are sending, what are the length of the packet, what is the next packet, what are the number of gaps in between. We need so many things, because if it's not odd and it's even, that is the incorrect thing. And even, let me show you one more thing. 0 1 0 1 and 1. So I basically took the third case, which was showing us the 5 digits, and in this case, even if I say that 0 and 1 added, so it will going to be 7 digits or 7 bits. It's still incorrect, but we do not know how many bits were originally transferred from the source. So we need to correct all these things. So we need to learn about the source, we need to know about the receiving end, we need to learn about the source, receiving end, and after we solve all these problems, only then we can correct and do the error correction. That is also called as parity bit correction. And after that we can transmit and receive the signal in the fullest way. So nowhere it's gonna be the relief, it will always going to show up something. So we need to work on that thing. Well, I will try to add up the notes of these all the communication things so that you can learn and get more curious about that, and if this brings curiosity to you, you can understand that this is something that you need to learn. So I'm ending the section here because we cannot cover everything about this thing. I will try to make a new course especially based on this section, in which we will discuss everything. And if you wish to learn, you can start directly by using the articles, books, or questioning. You can just simply ask the question in the Q&A, and I will be happy to help you. You can take the help. There are so many great instructors on the subject already. You can go and learn from there. So this is all about it, and now we can have the saying that it's the end of this section. So congratulations, my dear friend, you just learned about the digital analog communication, and now you cannot call yourself no voice in the subject. You know, you got curious and you get the observating eyes that what actually happening. Well, if you go in the deeper details, you will learn about the Fourier series, you will learn about the networking, you will learn about the transmission, receiving signals, intermediate, what is the distance, what can be the height, which kind of the signal you can receive and transmit, the antennas in between, the capacitor, inductor, games, the broadcasting thing, the receiving thing. Well, it's a lot more that I can cover in one section, but I gave you a glimpse that where and how you can go. I gave you a pathway so that you can travel from one point to the point where you actually able to become a network engineer or digital analog communication engineer. Well, but what we are learning here is the digital electronics, and in this part I can cover to this much extent to keep this course to the line where we have started it. So now we reach to a point where we can start the absolute lesson, which is known as microprocessors that changed the entire era of the digital electronics. It brings the revolution. So we will meet in the next one. Till that time, take care, God bless, keep smiling, keep learning, keep growing, and see you in the next one.